Alright, let me take you back to ancient Egypt. So as you might know, Egypt has a north coast with a big old delta. Lots of water, because there's a big old river running up Africa, running north through Africa, through the Sudan, and so on, through the ancient Egyptian territories and whatnot, called the Nile. And that's the reason Egypt got to flourish, essentially, because the Nile is a very long river. So although it does flow through the desert towards the end, it starts off in some very lush, nutrient-rich parts of the world. And because it's so large, its floods are huge. Also because of where it starts and the way weather works, and that's way beyond my expertise, the floods are regular. So the Nile would flood every year, and that would put lots of nutrients out of the river onto the land, which means they could farm, hence civilization being able to exist. But when the water receded, it wouldn't go back to the same place because the sand would have moved during the flood. Which meant if you owned a field or had right to farm on a field, it may well have been a different place and a different size. And that meant that you would have to have somebody arbitrate which bit of land was yours and get the same amount back. Which meant for very boring practical reasons, tax and food, as it always comes back to, the Egyptians got very, very good at measuring area and got lots of geometry. So one of the earliest bits of maths, advanced maths written down, is from ancient Egypt, and this might even be from the Rhind Papyrus, but I've got to double check that now I've said it. About working out the area of a field which you know is similar to a square. So, one such problem, described in the papyrus, is that there exists a rectangular field. And it's known to be, let's say, 10 meters longer than it is tall. Which means that this height here, or this width here rather, I will call W to use some modern algebra. There's a square here that is W wide and W tall, so this area is W squared. And it's known to be 10 meters longer, which means that this whole length here is W plus 10, and this length here is 10, this area here is 10 Ws. So it's known to be some measurement, 10 cubits, we're going to use meters to keep it modern, longer than it is wide, and it's known that its area is, let's say, 3,000 meters. So let's keep track of that somewhere. So the total area is 3,000 meters squared. So the way they would solve this is not with these algebraic symbols. The way described in the book, in the papyrus rather, is to take this bit on the end and lop it in half. So this now becomes 5 and 5. Now if I chop this one off, because that height is the same as this width, because this was a square, I can cut that off and put it here. So I will get this shape now. And this shape here is the same field as before. Alright? This length here is that length there and that length there, and we know that's 5 because this was chopped in half. Which means that this is a square here, and that square is 5 squared is 25. So I now know that this edge here is the square root of 3,000 plus 25, and then we'll check if I've got my values right to make this make sense. Square root of 3,000 plus 25, yeah, is 55. But that is not any measurement of the field, because this square wasn't part of the field. And in fact, these 5 meters here and here are longer than W, are longer than our original square. So that means that this must be 55 take 5, and this must be 55 plus 5, which gets us 50 by 60 for the rectangle, which gets us our 3,000 meter squares. So they would literally chop a field up when they were solving this, the process they would imagine doing is chopping a rectangular field up into a thing that's almost a square and literally completing it with a adjustment. And that's why it's called completing the square. The symbolic algebraic stuff that we were doing didn't come till much later. Like, we're looking at Descartes at the earliest, really, which is, you know, 3,000 years after this was written down, at least, maybe 4,000, before we moved to the symbolic algebra. So their practical uses were all about actual areas of actual squares and actual rectangles, which is why they didn't have any of the negative values or the other exciting stuff that we can study more recently, because they were never, you couldn't own a field with a negative value, for example. So because of the Nile flooding stuff, completing the square. So I hope that was of some interest. Enjoy.